Hi, Miss Lugs here. We're going to do lesson 4.5 on negative exponents and reciprocals. Observe. 2 to the power of 6 equals 64. 2 to the power of 5 equals 32. 2 to the 4 equals 16. 2 to the 3 equals 8. Do you notice a pattern? Hopefully you see that as the exponent increases by 1, the value is divided by 2. Let's continue. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the 0 is 1. So it's continued on. Let's keep going. What happens if we make this 2 to the negative 1? If you take your calculator out and do this, if you take your calculator out, that will tell you it's 0.5. But as a fraction, that's 1 over 2. 2 to the negative 2 is 0.25, which is a quarter, which is actually 1 over 2 squared. And 2 to the negative 3 is 0.125, which is 1 over 8, which is 1 over 2 cubed. So it continues, all right? And let's do it for 3's. So 3 to the 6. Let's see what happens with this. 3 to the 6 is 729. 3 to the 5 is 243. 3 to the 4 is 81. 3 cubed is 27. Well, it's not dividing it by 2 this time. It's divided by 3. So there seems to be a connection between the base and what happens over here, what it's dividing it by. Which makes sense because as you go up the chart, you're multiplying it by 3, right? Okay, so let's keep going. 3 squared is 9. 3 to the 1 is 3. 3 to the 0 is 1. 3 to the negative 1. Your calculator will tell you that's 0.3 repeating, and you should know that that's 1 over 3. And 3 to the negative 2 is 0.1 repeating, which is 1 over 9, which is 1 over 3 squared. So our pattern does hold that as you go down, you're dividing by 3 and the exponent goes down by 1. So I'll introduce you to a new word. The word is reciprocal, and it's a hard word to define because it comes in pairs. Reciprocals are numbers that when multiplied together, the product is 1. So for example, 2 to the power of, I'll do this in a different color, 2 squared times 2 to the negative 2. Now if I change that into what that's equal to, this is 4 times 1 over 4, and if I multiply those together, I get 4 over 4, which equals 1. And if I go back up and do this as exponents, I get to, if I use the exponent rules, that's 2 plus negative 2, which is 2 to the 0, which is 1. So it follows the exponent rules. These are reciprocals, because if you multiply them together, you get 1. That's just an important word for you to know. Okay, we have a rule. We found a rule here. So the rule that we can write out for this is that x to the negative n equals 1 over x to the n, and 1 over x to the negative n equals x to the n, as long as x is not equal to 0. and n is a rational number. Okay, so what this means you do, that's what the rule is. Oops, do I still have my text box? No. What this rule means is that if you have a power, if you move a power from the numerator to the denominator, or vice versa, you change the sign of the exponent. Okay? We'll come back to this later, but that's the rule. So if you're moving it from the numerator to the denominator, you change it. And also, you generally want to leave your exponents in your final answer as positive. We'll come back to that as well. Okay, let's do some examples. Evaluating powers with negative integer exponents. So 7 to the negative 2, this becomes 1 over 7 squared. We move it from, it's effectively in the numerator in this one, move it to the denominator and make it positive, and this becomes 1 over 49. And let's just talk about checking your answers here. On all of these questions, if you're allowed to use your calculator for this part of the question for the test, oh, for crying out loud, check it. Okay? So you take out your calculator and you go 7 to the power of negative 2, and you get 0.20408163. How long did that take me to write that down? And then I take my calculator and I go 1 divided by 49. Oh, it's the same number. Yay, check. I know that my answer over here is correct, and I can move on. Okay, I didn't do something silly like write 36 or just write 7 or something. It's really easy to check. Okay, this one. This one is a little, there's a short way to do this and a long way to do this, and I have to do it the long way for you the first time so you see how it works. So this equals 1 over 10 over 3 to the negative, or sorry, to the positive 3, because now I've moved it to the bottom. Let's make sure that that looks like just a positive 3. I've moved it to from the numerator to the denominator, so my sign of my exponent changes. Now, you need to be careful with brackets and lines, because if this had been to the positive 3, well, no, you're going to end up with things that look like this. And you need to be really clear, is this 1 over 10 over 3, or is it 1 over 10 over 3? So make sure that you're making your lines big enough to be clear which is the numerator and which is the denominator that has a fraction in it, okay? Okay, back to this example. What this actually means is 1 divided by 10 over 3 cubed, right? That's what these lines mean. They mean divided by. They're fraction lines. They mean divide. Life is easier if you get that straight in your head. Okay, I can't divide that yet because it's just one big thing. So I'm going to rewrite it as 2. I'm going to move the exponent. So this is 1 divided by 10 cubed over 3 cubed. Now, when I divide fractions, I invert and multiply. So this becomes 1 times 3 cubed over 10 cubed, which is just 3 cubed over 10 cubed. And then I wouldn't actually do this if I were trying to solve this, but I'm making a point here, so I'm going to rewrite it as 3 over 10 cubed. Okay, now I will show you the shortcut. And that is, you flip what's inside the brackets. So this becomes 3 over 10. You keep it in the brackets and you rewrite it, and you make the exponent positive. And ta-da! Same thing we got. Pretty cool, huh? Okay, now I can simplify it. So this becomes 3 cubed over 10 cubed. So this equals 27 over 1,000. Now, I really want you checking these, so I'm going to show you checking this again. So I get my calculator, I go 27 divided by 1,000, and I get 0.027. I'm writing it over here because this is the answer. This is not the answer. Okay, then I go back and I get my calculator and I go bracket 10 divided by 3 bracket to the power of -3. And I get 0.27, so I put a little check mark over here to say, yes, I've checked it. That's right. This is my answer. Decimal answer is not the answer to this type of question. Okay. All right. What's the rule we did here? Well, the rule looks like this. A over B all to the power of -n. Oops, let's make that look like -n to the power of -n equals B over A to the n. As long as, oh, just ignore this part. Sorry. As long as A is not equal to 0 and B is not equal to 0, because it doesn't work if they're zeros. And I want to show you, this is just a more general, this is more general than Rule 4. And you can use this instead of Rule 4, and I will show you that in a minute. First, I want to do one more example of this. Okay, so let's do this example. -1.5 to the -3. You need to quickly recognize that 1.5 is 3 over 2. So this becomes -3 over 2 to the -3. So I'm going to flip what's inside the brackets. That's what this rule is. Flip what's inside the brackets. This becomes 2 over 3. I have to keep the negative inside the brackets, and the negatives float up, so that becomes -2 over 3. And I'm changing the sign on my exponent, so that becomes to the 3. So this becomes -2 to the 3 over 3 to the 3. And these brackets are really important on the -2 because the whole thing is being cubed, not just the 2. Okay? So this becomes -8 over 27. Okay? Now, if you had just taken your calculator and gone -1.5 to the power of -3, you would get -0.296296, which is not the correct answer. The correct answer is the fraction. Okay. However, for checking purposes, I can do that, and then I can go -8 divided by 27, and lo and behold, I get the same answer, which means that my answer is correct. Okay? All right, your turn. Go ahead and do questions D to F, and then come back, pause the video, do the questions, come back and check your answers. Okay, I will quickly write out the answers for these. And if you get them right, you can skip ahead. So this is this is 1 over 9. Oh, don't skip ahead yet. I want to show you how this works using this rule. So this is, if I think of this as 3 to the -2 over 1, I can think of that as 3 over 1 to the -2. Because 1 to the anything is 1, so that's okay. I can do that. And then I flip it, and it becomes 1 over 3 squared. So that's 1 squared over 3 squared, and the 1 to this anything is still 1, and so that's 1 over 9. Okay, it's a little more complicated doing it that way. I just wanted to show you that the rule does apply even if one of the numbers is 1. Okay, the answer to E is -64 over 27, and the answer to F is 10,000 over 81. So if you got those, you can skip ahead. Okay, e, it's got a negative exponent, so we want to change that to a positive exponent. So we flip what's inside the brackets. So it becomes negative 4 over 3, so the negative floats up, cubed. So this becomes negative 4 cubed over 3 cubed, which is negative 64 over 27. And this one, we need to change this to a decimal, which is to a fraction. So it's 3 over 10 to the negative 4, which is 10 over 3 to the 4, which is 10 to the 4 over 3 to the 4, which is 10,000 over 81. And check it with your calculator because it's so easy to check it. It makes me very sad when you have careless mistakes that you didn't catch because you didn't check it with your calculator. Okay, doing powers with negative rational exponents. So those ones we've done so far had integer exponents. Now there's nothing new in this. This is just putting together some things that you've done before. So this becomes, usually the first thing you want to do is get rid of that negative exponent. So this is going to be 1 over 16 to the 5 over 4. And we make our exponents positive because it's now in the denominator. Oh, I'm going to make that look like that. Make that look like a 4. And an equals. Okay, so this becomes 1 over the 4th root of 16 to the 5. Now there's another way we could write that, but we've learned by now that it's fast. It makes more sense to take the root first and then do the exponent, right? So this is 1 over 2 to the 5, which is 1 over 32. And this one, first thing to do is get rid of that negative exponent by flipping what's inside the brackets. So this is 36 over 25, all to the 1/2. Now I know there are some of you that can look at this and just go right to the answer, but please, please write this step, this one we just did, because it's so easy to think you're getting the right answer and make a careless mistake here. So just write that one. Okay, so then this is 36 to the 1/2 over 25 to the 1/2, which is 6 over 5. Okay, and that's easy to check with your calculator. Okay, pause the video, do the next couple questions, and then come and check your answers. Okay, I'll again give you just the answers and you can skip ahead if you get them right. So this is 1 over 4, and this is 64 over 27. Okay, so this becomes 1 over 8 to the 2 over 3, which is 1 over the cube root of 8 squared, which is 1 over 2 squared, which is 1 over 4. And this one is, first thing we do is flip what's inside the brackets. So 9 to the positive now, 3 over 2. So this is 16 to the 3 over 2 divided by 9 to the 3 over 2. So now it seems really complicated, but you just grind through it and do each piece individually. So 16 to the 3 over 2 is the square root of 16 cubed, and this is the square root of 9 cubed. Now you don't need to write the 2 in here. I find it helpful because it reminds me that that 2 needs to go somewhere, but it's not wrong if you don't do it. Okay, so the square root of 16 is 4, so that's 4 cubed over 2 cubed, so that's 64 over, sorry, that's not 2 cubed, that's 3 cubed, 27. There we go. Okay, almost done. This last part is really straightforward. You're just using a calculator, okay? So paleontologists use measurements from fossilized dinosaur tracks and this complicated looking formula to estimate the speed at which a dinosaur traveled. In the formula, v is the speed in meters per second, s is the distance between successive footprints of the same foot, and f is the foot length in meters. Use the formula to estimate the speed of a dinosaur when s equals 1.5 and f is 0.3. So it tells us we were trying to find the speed of the dinosaur. It told us that the speed of the dinosaur is v. So the formula is already laid out in v equals. So all you need to do is plug in those other numbers. Oops. You do need to write it out properly though, correctly. 155 times 1.5 to the 5 over 3 times 0.3 to the negative 7 over 6. Now, there's no way you're going to do this and get an exact number. You're just going to plug that into your calculator and you're going to get 1.24 meters per second. So pause the video, make sure you can get that with this, and then go ahead and do the next question. And then come back and check your answer. Okay, for this one, we're just plugging our numbers in, just like the one above. So 0.155 times, oh, we need to find S and V this time. So S is, it says up here, S is this distance between successive footprints of the same foot. So there's S right there. S is 1 meter. And in this one, F is the length of the foot. So it's 0.25 this time. So 0.155 times 1 to the 5 over 3 times 0.25 to the negative 7 over 6. Put that in your calculator, you get 0.78 meters per second. And we're done. See you in class. Bye.